Welcome students to another video lecture with Mr. Connect. So before I have you pause and copy this down, you're also going to need your Chapter 3 vocabulary ready for this lesson as well. So make sure to have your Chapter 3 vocab somewhere ready you can look through when we go over this video lecture. So pause here and copy down what you see. Awesome, welcome back. So what we're doing today, we're learning how to multiply rational numbers. And just to keep on reminding us, we call them rational numbers because these are numbers that are capable of being written as fractions, which also means they could be written as a terminating or repeating decimal. So rational numbers, and we're going to learn to multiply. So we have our first example here, our guided example. And step one says to write all numbers as fractions or improper fractions. And in our model, there are no mixed numbers, so we've already written them as a fraction or as an improper fraction. So we're going on to step two. Step two means to reduce. So this is the first point where we're going to go to our Chapter 3 vocabulary, and I need us to make sure we fully understand what Chapter 3 vocab is. So go ahead and pause here and get to your Chapter 3 vocabulary. Awesome. So I, too, am going to jump to the vocabulary just so you can see what we're talking about. So we're looking at this word reduction or reduce. And what I really need to stress is that many of you may misunderstand what reduction means because it wasn't fully explained to you correctly. So when we reduce, it's called reduction in the center of the fraction problem. It's called simplify at the end. So in the middle, and when we cancel the same value on any numerator with any denominator. And I bet I'm going to prove to you that you have trouble with this word any in the next example. So again, when we reduce, it's any numerator with any denominator. Let's get back to our note now. Okay, so can we reduce any numbers in this problem? Go ahead and pause here. Try and think about where to reduce. Okay, welcome back. I hypothesize many of you noticed we can reduce the 6 and the 21. And what number can we reduce 6 and 21 by? Yeah, if you said 3, you're correct. So we're going to divide 6 by 3, and it turns into a 2, and the 21 by 3, and it turns into a 7. Now, many of my students, when they come into this part of the lesson, they think since we did reduce once, we're done. But that's not how reduction works. It is supposed to be done until the only number in common is the number 1, until you have it in simplest form. So, do you see any other numbers we could reduce? I have a feeling many of you are looking at this 14, negative 14, and this 7. But why I wanted to challenge you with reduce is, couldn't I reduce this 7 and this negative 14, which are directly on top of each other? There's this word we're never going to use when we talk about reduction. It's this word cross. Cross doesn't apply here. I'll teach where cross does work. So I'm actually going to reduce this 7 with this negative 14. And now, do we have any other numbers that are capable of being reduced? No. So that's when we move on to step 3, multiply straight across. 2 times negative 2 is negative 4. 7 times 1 is 7. So our answer is negative 4/7, and we just need to double check. Do 4 and 7 have anything in common? No. That's how you know they're in simplest form. The only number they have in common is the number 1. Okay, moving on, we're going to learn how to multiply decimals. I'm going to have you copy down these steps, and we'll actually go over this model in our class. And it's because we don't actually have this standard in 7th grade, but I think it's something you need to be reminded of so you know you're doing it correctly. So pause here, draw your squiggly line, and make sure to write how to multiply decimals. And then we're going to actually move on to the next examples. Awesome, welcome back. So here is our next example, example 1. Like I said, we're going to go over how to multiply decimals in class so I can show that. I think these steps do make sense if we use them correctly, but we don't have a model in here. But I'm going to show you example 1 and example 2. I need you to realize, though, when we do example 1, you're likely going to need a full index finger's worth of space to do this problem. So underneath example 1, use your index finger, that's your pointer finger, place it vertically on your paper, and you'll likely need about that much space to fill out the problem. Awesome. Welcome back. So first thing we need to do with example one is we're going to circle the words we care about. And example one is not a simple problem. It's a great model that many students try and do this all in one step, and it's not done in one step. So let's split our notes. And I know my split doesn't look like I cut it in half. And you're going to say first attempt or my attempt on the left, and then you'll write down my work, Mr. K's work on the right once I show it to you. So go ahead and pause here and attempt to solve example one on your own and realize the words in this problem really matter. Awesome. Welcome back. Hey, so I'm going to slide over your attempt so I have space for Mr. K's. Okay. And here we go. What's the first thing you may have circled? There are 60 students in this speech contest. We're talking about a speech contest. And the word yesterday is likely going to matter. 2/3 of them gave their speeches. Again, this word gave is going to be important. Today, 1/5 of the remaining students gave their speeches. All right. And then the question part, what we're really focused on. We're bracketing. We need to be able to answer this part. How many students students still haven't given their speeches? Do you already notice something about the phrasing they gave us in the word problem and what this question is actually happening? Okay, here we go. So we have left to right, 60 students. We're starting with 60. Yesterday, 2/3 of. What operation is of? If you didn't go back and look at your 1, 2, 1, 3 notes to find that wording table, you should right now. Yeah, so what operation is of? You're right, it's multiply. So 2/3 of them, and what we're actually solving for here is the number who gave their speeches. These are people who gave their speeches. Just in case you couldn't see that writing, it's G-A-V-E. Okay, gave their speeches. So step one, or we wrote them down, these are fractions, this invisible one's below it. Step two is reduce. What number can we reduce in this problem? Yeah, you're right. If we reduce the 3 and the 60, and what we end up with is 40. It's important you understand what this 40 means, though. This is students who gave their speeches. So in order to talk about the next day and the number of remaining students, what am I going to have to do with this 40 and our original 60 in the problem? Yeah, we have to subtract. So this is yesterday. We had 60 people, 40 of them gave their speeches. How many are left? 20 are left. All right, let's keep on going down. This is the next step of our problem here. So now, on today, we have 20 students left. 1/5 of them gave their speeches, and those are the ones remaining. So let's find out. Keep on squiggling this off, and this is today. Gave. Okay, we can add our 1 in here. Step 2 says to reduce. What number can we reduce in here? Yep, the 5, and this by a 5. So we end up with 4 students. Is the answer 4? No, this is 4 students gave their speeches, and this question wants to know haven't given their speeches. And this is really common to an SBAC question. This is not a one-step problem, and many of you likely tried it to do it all in one step. So our last part of this problem is we had 20 today, 4 finished. We have 16 who haven't given their speeches. So our answer for this is 16 students have not given their speeches. That's the answer. How many of you got that right the first time? That's impressive. Great job. So since this video lecture is getting a little longer, I'd like to show you the last 2 examples. Example 2 you've already copied, and example 2 is going to take about that index finger of space also. Go ahead and copy down example 3 also. I'm going to have you pause here, and I'm going to go over example 3. Hey, welcome back. Again, we're going to do example 2 in class together, and let's go over example 3. We're using the most used property of mathematics one more time, like we do often all the time. What skill or what property is the most used property in math? Have you said substitution? That was right. So we're going to write our expression down with empty parentheses. We're going to place our numbers into those parentheses. And this is a great model that it does mean to reduce with any numerator and any denominator. So I'm going to reduce this 2 with this 8. And I just did that because I wanted to. I know I could have used the 6, but I'm trying to model that it's any numerator with any denominator. The key is you can't do a numerator and a numerator, or a denominator and a denominator. It's any numerator and any denominator. So we cross that 2 out, we get a 1. We cross the 8 out, we get a 4. Is there anything else that could be reduced in this problem? 6 doesn't go into 7, 6 doesn't go into 5, 7 doesn't go into 4, 5 doesn't go into 4. We can just multiply straight across now. 24 over 35 is the final answer. And again, we just double check. 24 and 35 have no other number in common but the number 1. Well, that's it, students, for our video lecture on multiplying rational numbers. So if you have any questions, please remember to use our question columns throughout this note to write our questions down, and I'll see you in class.